Well, that explains why no one was here. Hello, everyone. I was fumbling along, so this is perfect. I practiced. Just everyone in the classroom gets to hear me hopefully get better the second time around. So sorry for the 1 minute delay. Welcome, everyone. Oh, yeah, look, here you are. Sorry. Welcome, everyone. And also, the classroom got quiet with the sort of practice minute there. So welcome, everyone in the virtual world. We've been, and in the classroom, we've been all looking very much forward to this lecture with Dr. Lynn Courtenay. She is a professor emeritus from University of Wisconsin-Whitewater. She also has an honorary research appointment at the University of Wisconsin-Madison in the art history department. She's held many done a lot of incredible things and held many interesting positions. She's the past president of AVISTA, which is the Association Villard de Notre, for the interdisciplinary study of medieval technology. She's written a lot of articles for the Oxford Dictionary of the Middle Ages and involved in the Hofsummer book that most of you students should know by now. She has participated in several NEH grants and has been a fellow at the Princeton School of Architecture. Their list keeps going. I could keep talking, but I would like to make time and space for Dr. Courtenay. She's one more thing I wanted to add, that she has been teaching at the University of Wisconsin-Whitewater in the Department of Art History, covering ancient and medieval art and architecture, as well as the introductory art history survey that everyone has to start with in school. The sort of cave painting to the Italian Renaissance drawing. That's what but she's got a lot of really interesting, I can't wait to hear this, and I know the students have tons of questions, so I would like to turn this over to Dr. Courtenay. Thank you.
Students know she is.
Oh, I'm gonna do this. So I'm gonna switch to the full screen. Okay. All right, so no one's seen it yet. Let's start by sharing the screen. All right. Then that way. All right. We set? All right. Welcome.
Okay, thank you. It's really a pleasure to be here to talk about one of my favorite subjects. Today, I'm going to sort of invite you to experience a wider aspect of timber framing. I know you all have done trusses, you've done beautiful drawings, you all know a lot about the woodworking aspect and the tools, thanks to Gunnar's great talk. But what I'm going to do is primarily historical things, and I'm going to show you other things than Notre Dame, because you can't really tell what's special about Notre Dame until you know the context, you know what else was around it. So that's the point of this. This is just a focusing slide, but it does show on the right is Meaux Cathedral, because I had a decent light, and it shows you the heartwood and the squaring of the beam, and you're all going to be doing this. So you're going to be taking your adze and hacking off the bark and the sapwood and all of that stuff. And just to put things in even a wider perspective, here's of course a map of Paris from Gallia. It doesn't give me a source. And the poster in the middle is from the bombing of Reims Cathedral in the First World War. And so it's Paris or France has not escaped other tragedies and cathedrals. So now let's see. Now, how do I just click this?
Yes.
Okay. So what we're going to look at, just to have a wider perspective, is, and Viollet-le-Duc did this, he divided timber in his famous article in Charpente in the Dictionnaire. He divided timber into two major classes, the seen and the unseen. So when something is visible, it has an aesthetic component. And what you're doing is the part that is maybe is pure structure, which has the engineering component. So what I'm showing you now are two examples that are really concerned with the aesthetic aspect, particularly in France. And most all of these roofs, Clou Manor was not tile, but most of these churches in France, you would have a paneling so that you would just see the trefoil form covering the building. And this is an amazing building. It was a total wreck when I first visited it. And it's been restored as a music hall. So if you go to Belgium or you go to Ghent, you must absolutely see this and go to a concert. So, and then what happened here? Oh, wait, it's not, oh, what's going on? It's not going forward.
We can just move. I think you can just use
Oh.
this.
Is it in slideshow mode?
It should be.
It should be in slideshow.
No. There we go.
There we
Yes.
go.
So just.
So,
this-
okay, there should be another slide of bylaw. Yeah. This is the building as a hospital. This is an open ward hospital. And the iron tie rods were the marshy ground, the foundations were sinking. So tie rods were put in the 17th century. And so this was what it's like. This was a pre-war early photograph. And one thing we'll be talking about is that the trusses are divided into principals and secondary trusses. And I just learned that you're going to also be building the secondary trusses of the choir of Notre Dame. And what's important is that there's a big, big difference between the primary truss and the secondary truss, both in terms of the amount of timber used and the biggest beams in terms of section are going to be in your primary truss. So this is biloc, and one thing that you can see in the, I guess, lower right-hand side, just behind where the iron tie rod was put in, this, you can see how they've pieced together what is called a base croc. That's probably nothing you need to know about, but it's technically a raised base croc. But what they've done is they've emphasized the profile using the round arch molding, as well as piecing this in so that it's all one smooth arch. And so that's an example of the aesthetic. What did I do? Okay, down here, okay.
Yeah. So you can go back.
Wait a minute. Yeah.
Yeah.
Okay, another example of roofs that served both an aesthetic and an engineering function is the roofs above the vaults at the lovely little Romanesque church at Boscherville in Normandy, if anybody's been there. The thing is that the vaults were inserted after the roof, and you can just barely see the molding of the former window. And to make room for the vaults, they cut off the tie beams. And so here you can see the big square section of the tie. And it is always going to be the largest piece of wood in any truss that you build. And also, we noted in this, and this is, by the way, it's in all primary research. You won't get this in a book. Well, we've published an article on it, but they're grooves. If you can see the grooves, those are to hold ceiling planks. And so the ceiling planks in churches would very likely be covered with a gesso and painted, or covered with some kind of masking. So that this is a roof that's essentially serving two purposes, the panel ceiling and actually holding up the roof. Now, one of the two major approaches to studying medieval roofs is classification or typology. And this gives us a database, essentially, going by typology. And I was involved in a project in which we were trying to figure out what the original roof was for Jumièges Abbey. And so what we did was assemble a huge number of roofs with common tie beams from the archaeological evidence. And there's evidence at the other end of some sockets for a tie beam. And so it has 3 roofs. And I'm sure you can all decide, which is the medieval one, which is the Romanesque roof, which is the middle scar. The Gothic one is too high and cuts into the windows. The lower one is a later early modern roof, which cuts into the archway. And this is only the one that fits properly. So we have 2 clues. We know what the pitch is, and looking at some of the details, there are some sockets for the rafters, so we know what the rafter scantling was. Some diagonal slots, and then some great big tie beam slots. So we could figure out basically the proportion that, like Boscherville or other roofs, you have a big tie beam section, usually about 24, 25 centimeters square. And then the other things are incredibly light, like between 7 to 9 centimeters square. It's a very, very big difference. So classification is the way roofs were studied ever since roofs were studied, I think. And we just assembled a group. Now the person, I'm going to shift gears now, the person who really went in a different direction, which is the direction we all go in now, which all research and scholarship is, and particularly Patrick Hofstadter's book, is to look at evolution over time. So that's change over time in design. And so in order to have change over time, you have to know the dates. And so the dates are today determined by very sophisticated dendrochronology. And there are lots of chronologies, they're called chronologies, they're essentially different geographical databases. So people may have a database for Calvados or something near a certain town, like Jumièges is in the Seine Valley, west of Rouen. So there might be a chronology for each area. And then the idea is to match the rings. Oh, everybody knows what dendrochronology is, right? Tree ring width. Okay, so you measure the ring. In other words, you put in an algorithm into the computer and you've measured core samples and you measure the ring widths. And the ring widths tell you the years. There's an annual ring in oak every single year. And you can tell if there's wet weather or dry weather, or they don't grow very much. And actually this whole science was pioneered by an American in the Southwest, studying the bristlecone pine. But this has become a major science. But pre-dendro, a man named Henri Deneux, who's sort of the grand master of medieval carpentry in France in the 20th century, Henri Deneux began to study medieval roofs and to make a lot of drawings. But he's primarily known as the restorer and the designer of the truss of the new roof at Reims Cathedral, which was bombed. And here's this dramatic scene of it, of course, caught on fire once it was bombed in the war. And then the roof, which the Parisians decided not to build, is essentially a roof of steel and with some ceramic use in there, but it's primarily a steel roof. And you can see the joints with, maybe see the joints with pins and stuff. And so what Deneux did was he kept this sort of running account of the different roofs that he was able to examine And these are all in the Centre de Recherche de Monuments Historiques in Paris. And he made wonderful models. And this is just an illustration of his models. And these are very useful three-dimensional models, scaled models. And there have been a huge success for researchers. And I know Patrick has worked in this quite a bit. So going on from Deneuve's evolution of carpentry, we start to move into development in trusses, in truss design. And this is just a very simple idea of what an early Romanesque roof looked like. Could have been Jumiez or something. So a very basic truss with one single collar, a tie beam, I don't need to point, and simple rafters. Now, so what happened? What's the difference? What's the difference between this really super basic design of Saint-Pierre et Montmartre? And it was nice to find something that was known, because Saint-Pierre et Montmartre is also a major church in Paris, which surely the people would have known. And if you notice, the dendro date is 1164 to 1167. Notre Dame is roughly 1160 to 1220 roof trusses. So they're basically contemporary. Saint-Pierre is also a major status, a high status church, because it was where Saint-Denis was supposedly martyred, carried his head, his severed head to Saint-Denis, where the real Saint-Denis is north of Paris, just north suburb. And so it was, you know, the church had some prominence. So it would have been well known, I think, or known to the bishop, certainly the chapter house, the bishop, the chapter at Paris, and so forth. So we look at what happens. First of all of the rafters are the same. There's no principal rafter. There's no principal truss. All the trusses are identical. And so that means that there's a big fat tie beam at every truss. And this is maximal use of woodland resources, because it uses much more wood, much larger wood. So what has happened in the development of Paris, once, you know, very much contemporary situation, is that the master carpenter, who's really an engineer, master carpenter built lifting, hoisting machines, all kinds of stuff. And so master carpenter went to a different system. So they're intermediate trusses. There's 6 intermediate trusses between the principals. And that is a huge leap. That is really a very important leap in terms of engineering and design and basically everything, and resources, forest ecology. It all kind of comes together with this respect for the resources. Are there any questions at this point? Anybody?
So are you saying that's an urban, like a kind of rural to urban shift, or?
No, not at all. No, it's time and expertise, and probably the group that the carpenter was associated. And so they all would go through the traditional training that Gunnar talked about. I believe it's the apprenticeship, then he was a journeyman, then he was a team player, and then finally he would become a master carpenter. So it's a difference in that. And the other thing is to point out the fact that the general idea is the Middle Ages was just there, and it was static, and it stood there forever and ever in a history book. Well, that's not true. Things happened very fast. And so within 5 to 10 years, there might be a complete change in what the going design was. So it was like fashion in a way, and it changes constantly. And that's very interesting. And we're talking about the same place, roughly the same time. So the rural urban, when you go to rural, you get things a little bit later, unless the church is super important. And as you go east, you know, towards Eastern Europe, you get a basically time lag there. But in the Ile-de-France and prominent archbishoprics in France, you tend to be very au courant in what's going on. And you know, there may have been some competition with this too, which is often stressed in the context of Beauvais. So here I've given the French terms, which I guess from reading the syllabus, you're all supposed to learn these. Don't know. Well, you don't have to talk to the French carpenters, I guess, because they're not going to be here, sadly, because we won't let them in the country. So let's see. So let's take a little closer look at the Paris choir and see what's going on here. And so you see the secondary truss, the secondary rafter couple is very light and much fewer members than the primary frame or truss. So there's a huge difference there. And I think the rafters are around 7 to 8 centimeters. You have that drawing that has everything measured. And the sections of the tie beams, they vary by bay to bay. No, as far as I know, different trusses, different parts of the building, there's always some variation. And this was shown in Lindsay's talk and Andy Talon's drawings, which the digital scans, which show the deviations. Well, it's also true in the carpentry part. It depends on who's cutting it, who's supply and demand, all these factors. So, so what we have is a Bay system of construction, and this stayed with us forever and ever till the end of the Middle Ages. So nobody ever went back to putting every truss the same. It was just too expensive, costly in terms of resources, and labor intensive. Once you start hewing away on your big oaks, you'll see what that's going to be like. So bear this in mind. And looking at what the carpenters actually built, we can ascertain what they were concerned about, what was driving the design. And as you know, Paris was the tallest building in the 12th century. It was the skyscraper of Paris. It was the tallest building in Paris before the Eiffel Tower. And so it was just this huge challenge. And so you're putting a roof, a biggish roof, on top of a very tall building, about 100 feet. And the choir is about 13 meters, 12.5, depending on where you measure, 12.5 to 13 meters internal span. And I measured the wall at different places. I couldn't in the choir, but in the nave, and you stick your little measuring thing through the hole to find one that doesn't have a screen on it. And the wall thickness is only about, 60 to 74 centimeters wide. So it's less than a meter thick, and it's huge. So all of these things are making a great deal of difference. And what we're going to look at, and what's interested me especially, is how the roof is seated on the wall. Because I think, my thesis is that this is really the success or failure of the roof, is how it sits on the wall, and that it sits firmly, and it doesn't tilt, and it doesn't waver, and it doesn't fall down. So that is the purpose. There's also the purpose in erecting these roofs that the carpenter had to build work platforms. And so this just shows an example of a work platform, a hamster wheel or treadmill for lifting things. And so all of this had to be designed. And so the roof structure, the tie beams as anchored onto the wall, they had to sustain all this extra weight. So we have a tremendous amount more loading on the system than we would have in just a roof over a house or a manor or something. So we had these huge platforms to haul up the timber, to haul up the stone, all of these things. And so it's very important. So now what we're going to look at some details of Notre Dame and its seating on the wall, and to pay attention to what the carpenter has done, because he really wants to make sure that that tie beam doesn't twist, so that that it doesn't sag, and that it doesn't shift outward, and it doesn't lean. All these things that can happen. And you'll discover that when you try to lift your frame, what can happen when you do this for real. And I'm really excited that students are having a chance to do something non-digital. And I have to say, some of these slides, pictures are out of focus. These were taken in the 1980s, before the digital age, before the internet, before the euro even. Think of that. I mean, this is ancient in terms of where we are now. And so basically, you're going to see some slides that are out of focus as we go along, but you're going to not only see the out of focus, not only going to see the out of focus, but you're going to be privileged to see the pigeon poop as well, the grime, the pigeon poop, all of this stuff. Well, Andy Talon's drawing or scan photograph of the choir is very cleaned up. It looks like somebody went in there and swept it, or he did something to it, because it looks so tidy and clean. And there are no dead birds and all this stuff that you find there, you know, rats, dead birds, all this stuff. And the other thing that's interesting about Paris that becomes so obvious from the roof that wasn't that obvious to art historians in past decades is the difference between the height of the choir and the nave. And there are lots of discussion about when they were doing what. And Caroline Brazilias has gone into this. Clark and Mark went into this question, and we discussed these things together. And so when you see the roof, you see that there's a big drop, and we'll see that very clearly. But simply what I did is I was on the tie beam, I simply dropped a string, you know, a little plumb thing, from the tri-beam to the crown of the vault, took it up, measured it, and it's about 2.5 meters difference in height. So that tells you that when they rebuilt the choir, they're trying to match the nave. They're trying to join it up so there would be one big roof line. So as you see on the slide on the right, this is the exterior of the choir, and up above the sort of checkerboard molding is a whole new parapet. And it gets a little dicey because all of this was restored by Viollet-le-Duc in the 19th century. So the parapet, all the things he added, the buttresses were all restored by Viollet-le-Duc. So you have to look you know, for clues, more clues in the masonry. You go into the roof, you can't miss it, because you can see a line, a clear line, where there's the new roof and the old roof. And the nave roof tie beams are right close to the vault ground. They're very, very close. And so what you see here is that the vaults were still the same in the choir, but they had to raise the roof level. And they rebuilt the choir, but they rebuilt the choir pretty much the same at the roof level. It didn't have anything to do with the vaults. And that's the mistake people make, that the rebuilt choir might have had something to do with the vaults. It didn't have anything to do with the vaults because the vaults have nothing to do with the roof line of the building. So the vault is much lower in the choir compared to the level of the trusses. So you see the raised parapet wall, I think in both of these slides. The one on the right is sadly a bit out of focus. I was doing this research with a handheld Pentax 1000. I had no lights, no team, no ladders, nothing. So I was just crouching on places where I could crouch in this. So, you know, there's this bit of camera shake in there. And so, but this told me a lot. These are these little pigeonholes. They're covered by wire mesh. And so, but you have to find one where the wire mesh is torn or the pigeons have torn it off or something, some animal and has gotten to it. And you can stick your ruler through the wall. But here the mesh is all intact. So as we go on, we see that the master carpenter was really concerned with anchoring that tie beam on the wall. And if maybe just go back for a second, because he's put double braces. He's put this massive bracket down, if you look on the left, and double braces, and then a piece underneath the tie beam. Unlike Saint-Pierre and Montmartre, it has these wall plates that run along the top of the wall, and then the rafters are sort of joined over them. There's a kind of, they're cut out to fit over these ties along the top of the wall. So he's really worried about that roof moving and the structure moving. So he's taken enormous care to deal with this issue. And here's a close-up of the truss. You can see repairs on the left. You see the glorious pigeon poop and grime on the left. And this helpful drawing by Viollet-le-Duc, just in his, this is not Paris per se, but it's a good replica that you can understand how it all works. So you can see how that's stabilized by the longitudinal plates. And then it's got another piece that cuts across, and then the triangular base to prop up the rafters. And so triangulation is used frequently by the medieval carpenters to strengthen areas. You create a triangle, which, as you all know, is a form that does not deform. Everybody knows that, right? Okay, so that's the idea. So you've got braces, you've got triangular brace underneath between the brackets and the wall. You've got triangular bracing at the foot of all the rafters as well as the tie beams. So there's really an interest in this. And this is the choir, the detail of the choir, beginning at the turning bay. And in the last straight bay of the choir, I couldn't photograph this, is a tie beam, and the other beams radiate out in a circle. But what you can see here very clearly on both the right and the left is again, the triangular braces at the foot of the rafter. And these sturdy pieces that are called sole pieces that go across the two plates. So this is really, really stabilized. And there's been no reports of the roof racking, that is leaning lengthwise or, you know, wobbling. It's been a very, very stable monument. It's the masonry that's been the problem. I mean, that's what's been restored. There was some restoration in the 18th century, off and on, some replacement of parts in the roof, but basically it's as it was when it was done. And in contrast to the buttresses and the parapet and all of that. You can see on the left hand, I hope you can see it. You can probably see the empty mortise on the first, the principal rafter on the left-hand side. You can see this slot. Oh, well, you have the pointer, yeah. Okay, thank you. I always find these things very feeble. Okay,
Yeah,
this is
they
a
are.
bright one, okay.
A little red button,
Yeah,
upside down.
okay.
There you go.
There we go. Okay, so this is the empty mortise, indicating the reuse of original timber. And that's why we get such a broad dendro range of dates, something all the way from the late 10th century into the 13th or the first quarter of the 13th century, because they were reusing. So if you date this, you're going to get a different date than if, say, you date this or something that's maybe more recent. And this is all through the choir. And you said that the choir was the old, the sixth truss was the oldest.
I don't know.
You know, that's why you chose it?
No, we were given truss number 6. Carpenters without Borders asked Hans House to do truss number 6 because they did truss number 5.
Oh, I see.
Run
Oh, okay. Because I thought it
it.
had.
You can learn something different.
You learn something different. Everybody is. So that's, whoops, that's interesting because, whoops. That's interesting because, so basically you're doing the last straight day of the choir. Also, I should point out that I think Lindsay probably mentioned this, that the vaulting at Paris is 6-part vaults. And so the bays are huge. And so the 6th truss would be this on a half bay. The half of the bay is in the gallery and the aisles. In other words, you see it on the plan out there. There you have narrow bays, but in the actual choir and nave, you have the great big bays that were built. And 6-part vaulting, according to some engineering studies, requires or has less outward thrust than the quadripartite vault, but it has more thrust along the wall head. So, any questions?
What is the sole piece that the?
Oh, wait, excuse me. Wait a minute, I'm going the wrong, what's happening here? I'm thinking of going backwards. Okay, so just, yeah, just make sure I got the right arrow. I think the sole pieces are, okay, these are the wall plates, and you don't see the sole plate. The sole pieces are the cross pieces that the rafters are tenoned into. And basically, your joints in the Paris nave and choir are half lap, often with a round peg, or mortise and tenon joint with a straight tenon, also pegged, except for the climax is the tension joints. It's really hard to see the sole piece. That's the choir. But you see the end of it. That is the bloche, the sole plate that runs across. That's the rafter. And the thing is that this also provides longitudinal support for the frame, which is you're again going to appreciate very much when you try to raise it. So let's see. Where are we going? Yeah, there it's very clear in VLA how that works with the overlap. Some of us call this sort of trenching over. People use different terms for different things, but here you see the sole pieces, and they quite often overhang the wall face. And in essence, that sort of brings the total span a little inward, which helps with, if you think of the roof being, if you had it at the very outer edge, it would be much more subject to wind loading and to deflection, whereas sort of bringing it closer in, close to the inner face of the wall, increases that stabilization. So,
You said something, you said the 6-part vault had less outward thrust, but more somewhere else.
oh, longitudinal,
Okay.
along the wall head. And so, and that's been done by computer analysis. I think Robert Mark did that. I think he did that in his lab at some point. Well, the super thing that happens at Paris for the first time, as far as I know, is the use of timber in tension. And they don't do this in England. And I've had argument after argument. The English have tried to build replicas and they totally get it wrong, absolutely totally wrong. They don't understand tension in timber because they use big fat beams that are all mortise and tenon. They don't use any tension. And they tried to do it, but they never did. And so there may be some in the chapter house at York, but that's a whole nother ball game. So what we have here is a hanger, a spawn. And what this does, as you can see, I've marked it in red, this holds up the tie beam. It keeps it from sagging. These were not always used after reconstruction, but you've got a work crew, you've got platforms, you've got a treadmill, tread thing, treadmill, whatever, up there. So there's got lots of load on that beam. And so this is what the master carpenter, again, devised as part of the stabilization. And it's just brilliant. And from this point on, pretty much, we see this replicated over and over and over. It's really interesting to see that this was obviously the hot thing in roof trusses. And so, and the nave is even more elegant. So it just catches on at different places. Question, yeah.
Do you think they were using those, did they choose not to use those in some cases because they weren't having to use it as like a rigging device to help get things up, or was it just?
Well, I think in every Gothic cathedral of any size, they had the same problem. So they would have to, the roof structure, the timber work was always done before the vaulting. So they still had to have big platforms to, to hold the crew and all of this, as well as the vaulting material. So there's a big load on that. It depends on the scale of the building, and they had problems with sagging tie beams. They've had to replace sagging tie beams, and so and that was a perennial problem. But our brilliant master carpenter at Notre Dame devised this special joint. This one is kind of clunky, but it serves its purpose. Now, engineers, they sort of look at this and say, oh, it's overbuilt, it's so overbuilt. Oh, terrible structure. That's from an engineering perspective. But the engineers don't realize that they didn't have any mathematical calculation. They were using set squares, measured pieces, whatever. They had no mathematics and no way of doing this. So this is all empirical, intuitive, realizing how things work. And of course the engineers, oh, so overbuilt. But I would defy them to try to put a building up with a single beam and of that span with platforms and work crew and stones and all that stuff up there, not have some sag. But anyway, that's just I've been criticized for this. So saying, okay, so now we have this wonderful invention. And what's interesting is that we see it around Paris. We see it at other places. And this earlier one on the far left at Angers at the Chapel of St. John, and this has a huge span for this chapel, there is this sort of proto-hanger. It's a very weak piece of timber, but you see it's attached to the tie beam. A skinny tie beam, vaults like at Boscherville, put in later. They did some redesign of the chapel, but this is the original 12th century, late 12th century. Again, it's roughly contemporary with the first version of the roof of Notre Dame. If we look at the dates of 1182 to 1183, a good chance that the design was maybe erected, done in the late 60s, early 70s in Paris. So again, there's this very close chronological, once we've got Dendro, this close chronological overlap. So we find it in the nave of Paris. These are my favorite. Well, in Rouen has nicer ones, but these beautiful suspens in the middle slide. This is the nave, and you can see how trim and elegant it is for something that's not going to be seen. This is pure engineering. Nobody's going to look at this except fools like me. And so that is pure engineering. At Meaux Cathedral, which is very close in date and not too far from east of Paris, there is another attempt at this. This one's a little clunkier and it was hard to photograph because of the way the light was, but underneath the tie beam, there's a kind of saddle piece. And it's also got a hanger. I think you can see that. Write this out. Where are you, Dot? Don't tell me. Pushing it down. Okay. Oh, I'm doing something wrong. But anyway, the hanger is in the middle. Then there's a straight post with a mortise and tenon joint, where the joint has shrunk and been reinforced with iron strapping, because that happens all the time. It's also a myth that carpenters use seasoned timbers. We've learned from dendrochronology that most timber was used from about a year to a year and a half from the felling in the forest. So it's green timber they're working with, not seasoned timber. And so they're going to shrink. So that's another thing where engineers would say, well, it's overbuilt. So that you have a straight mortise and tenon joint on a post, and then you have another hanger. It's out of focus, as a lot of these things are, but it's just the nature of the beast. And so, so this spread elsewhere to Rouen, to other places. So, it's like car design and all that stuff, that people have to have the latest thing. And this is the last look. And I'm standing at a younger age. We're talking about almost 40 years ago, standing on the top of the nave hanger and you can see how I put my arm through. I don't know who took the picture. I think John Cameron took the picture. We see Villers spire, and I just love this low-tech post of the spire. You notice the fire extinguisher. So it's really old tech from the standpoint of things. And also you can see how the post is shrunk from this joint to the base of this. So, but what I think the picture of me shows is the elegance of the hanger. That it's tapered, there's a chamfered edge, all of this that wasn't supposed to be seen. But I think this is the sense that the master carpenter was an elegant craftsman as well as an engineer. And so that's it. I think I'm on time. And so there are questions.
It looks like there's almost a stairwell.
There is. There's a stairwell that goes up, and that's sort of at the base of it. And it's just, the stairwell is sort of over further to the right is the circular stairwell, and you get up on this catwalk. So basically, this is on the catwalk side, I think. What? Oh, I'm not on the mic.
No, I was gonna look in the Q&A and see.
Q&A. Okay, Q&A, I'll say. I took this slide, I think, from one of the Western Towers. And I say, I can't remember. I took some fellow art historians. There was this expat group in Paris in the 80s, measuring things and doing all kinds. So I took the stone people and sculpture people into the roof once I got access to all the keys. So, but anyway, I just think there's a dramatic change within a couple of decades. So.
Why didn't they use seasoned wood as opposed to the green wood?
Because it was easier to cut. It was a question of the tools. They'd have to resharpen the tools all the time. And also patrons, this is something I've realized over the years, patrons were in a hurry. They were in a big hurry. They wanted to get stuff done. They got the money, they want to go. Oh. Sorry, so I just talking to him. So the patrons, they really want to have stuff done as quickly as possible. And it's cost effective as well. And easier to cut, so it's time effective. But I think that's one of the main things, that it's basically easier to cut. So you're going to be working with green timber. So you try to get an old piece of seasoned oak, and you're talking about a real, you've tried this.
They have been working with dry kiln oak. And
Yeah.
It feels like bone, carving bone in comparison to carving green wood.
Yeah. Yeah.
Would that shrink more often? Is that what that used to tie, like later on, because the green wood would shrink more?
Yeah, it'll shrink more. But they know this. I mean, they went through apprenticeships since they were kids. They've been growing up with timber and woods and all of these things. They know what they're doing. And this is something that they really do know what they're doing. And, but the thing is the tension thing, it doesn't matter if it shrinks, because you all know what a tension member is. It's pulling. And it's brilliant because, and at every stage, I'm up on top of the collar, but there's another tension joint just above it. So it's anchored along the stretch of the timber in tension. It's very, very beautifully designed. And it doesn't matter if that's green wood or not. Okay? Any other questions? Yes.
Well, I want to hear your observation as a person with an intimate experience of the forest prior to the fire. What was going through your mind when you saw the images of the burning? Oh,
I was in England at the time. I was devastated. I was absolutely devastated.
And you obviously knew about the scan and everything, so was there a glimmer of hope that you knew that there was accurate documentation, or what was?
Well, no, it was terrible because I heard it all live on the BBC, because I was actually working in England at the time. So it was just live coverage. And so you could hear the distress, you could hear the moaning, the groaning, the fact that they didn't communicate, they went to the wrong place at the beginning, all of this stuff that, so when they went to the wrong place and there was the guys that received the signal to go to the wrong place, and he was new at this touch thing. So you're mad, and the first time you're at a computer and you're supposed to rescue a building. So, it was devastating. I didn't have much hope because of course this time the fire and there was a breeze. So it just went way up and like a tinderbox, just way up in flame. And it was so distressing to essentially watch this live or hear it live on BBC. So yeah, I felt a personal relationship with this building, and actually it was. I realized I wanted to do this because I did my thesis on an open truss, big building in England, Westminster Hall, And there was a lot of discussion about how the truss worked, what was in compression, what was in tension, big complicated joints, a span of, 22 meters, something like that. And so I started working with that. And then I realized the wall head, what was happening at the wall, where the roof and the wall connect. And what they did at Westminster Hall is they brought the roof, the primary load down a long way down the wall, so that the major, if you look at the vector, the major thrust, both down and out, is carried down the wall, which makes it much less likely for overturning. So I thought to myself, like poo, I said to myself, what happens in other buildings that I haven't ever seen? So then I started, well, what happens in a big, tall building like Paris at the wall head? And so the first thing I ever published was not such a great article, but it was, as Patrick says, it was the gem of more to come. He said, where roof meets wall. And so I was just looking at what happens how the roof sits on the wall. And so then I thought, well, I've got to go to cathedrals, and I have this friend in Paris, and blah, blah, blah. So I was so lucky because I was being a poor student at that point. No, I wasn't a poor student. I was a poor unemployed teacher at the moment, I think. I had a friend who was a CBS stringer, dear Ronnie, and she was staying in a magnificent apartment in the 7th. And the man who rented it very cheaply, had a beautiful collection of Asian art. And so he didn't want just anybody. So he knew her older sister. And so, and he wanted somebody there to protect his Asian art collection. And so I stayed with Ronnie. I could stay with her all these different times. I could take care of her mother on Armistice, on Normandy, D-Day, and all of these things. So I was really lucky. So I would go to Paris back and forth on different trips because I was otherwise occupied, little kids. So, any other questions?
Yeah, I kind of had a question of your thoughts. You kind of mentioned it quickly about kind of the engineering side of what we know now with numbers, and kind of how these carpenters, I think then, would now be skeptical of it because they had like this heuristic knowledge of how to do these things.
Exactly.
So it makes me,
Well, they had hands-on.
yeah.
Just like
So
you're going to be hands-house knowledge.
Yeah, so I was wondering if you just had any kind of maybe discussion on that as it applies to this and at a larger scale of what it means to like know something engineering-wise with mathematics and numbers versus like this heuristic knowledge of these people understood by looking and feeling.
Well, one thing you can gather by looking is that they didn't know how to add or multiply, particularly. So with all the numbering of the trusses, it's simply marks, 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 no multiplication at all. And but then the scribing is a very sophisticated practice, and that's what they would learn as apprentices and journeymen. They would learn how to scribe these joints. They would learn, they might inherit their master's templates and laying things out. I don't think they could perceive of what we do now with computers and everything, and the engineering ability to detect things. And the scanning stuff, you know, the 3D scanning, the stuff that Andy did. I mean, it's amazing that I don't think they could comprehend this really. It's way above their furthest dreams and thoughts. So does that answer your question? Or
Yeah,
not really?
I guess I was kind of getting at, do you think that all this extra kind of data that we have is...
Makes a big difference?
Yeah, or is it making a difference, or is it just noise? Whereas...
Well, you know, you're talking to an old lady. A lot of it's noise, in my opinion, because you don't see the real wood. And I looked at the scans and stuff. You see a two-dimensional you see the profiles, you see deflection, you see the geometry, but you don't see what's happening at the, the real nut and bolts of it was what's happening with the timber. And so, and I think Carolyn Brazilius is the same period, colleague, that she is a stone person. And she said, you don't really, this digital stuff is really beautiful, but she said, you really understand it when you measure the stone by stone and you look at it. You look at the building. You look at the fabric bit by bit. So there is some, not controversy, but a different opinion, really. And there are different opinions in dendrochronology, how you set up the algorithms and what you do with this and that. And they can sometimes give you a sort of leeway space with the sapwood heartwood boundary, which is called the T value. And they can estimate that from other chronologies or from the looking at the wood too. So they estimate or they guesstimate. So any other questions? Well,
We had a question, the university president stopped by and he asked why that pitch for the truss?
Oh, that's the common pitch of 55 to.
It was just.
Yeah, it's essentially the common pitch from tried and true. Most of the roof pitches are around 45 to 55 degrees. And the only one that's really different, I think it's either Rouen or Amiens has a steeper pitch. But usually, I think that's just tradition. Tradition is usually what this kind of things. And these people were traditional craftsmen. They were raised with, this is the way you do it, kind of thing. So, but that's an interesting question. So you tell them it's tradition.
But the Romanesque, we sort of thought that, but it wasn't that. The Romanesque one is
45 degrees, 47 degrees. Yeah, I think it's, Jumiège is 47 degrees.
Okay.
So it's in that common pitch realm. The real low one is from the Morris, who took over the building and saved it from total destruction in the 17th century. And that's a different look. They would have plastered ceilings and other things. So that's a low roof to design for a plastered ceiling. But, and then you saw the Gothic pitch roof in Jumiège. We can go back to it. That was a very steep pitch. And that didn't last very long for some reason. I don't know. But they didn't have hangers, maybe. So.
I have a question, and I think you have mentioned, discussed this a little bit before, but I'm always worried about the shrinkage.
Yeah.
It's a really high amount of moisture that the wood loses.
Mm-hmm.
You were talking to me a little bit about the sapwood and
I
structure.
know. I
of the wood.
studied this. I studied the wonderful biological forest studies of Oliver Rackham in England, for the English landscape, and all about trees, everything about trees. There's also a fascinating thing by you can read it in translation, the ancient Greek, what is his name? Who wrote about this, not the Silva, but anyway, I'll come up with an email. So, but the thing is that, if they wait a year, you're gonna only be waiting, what, a month, 2 months at the most? Yeah, so there's probably a degree of water loss that so they would maybe season it over a fall. So they fell in the fall and build maybe in the spring. If things were held up by the team or finances or the bishop or somebody, then they could carry it over to the next season. But so the next spring after felling would probably be one of the latest, but that would lose quite a bit of water. So it was in the range of, to get down to the hardwood, it was, I think you use about 60% of the sap wood. It's a lot.
A lot.
It's a lot. And so that's why the trees have to be so big. And what Oliver Rackham did is he studied woodlands. He's a woodland expert. He took the diameters of all these trees. And then the Dido people could tell, they have the diameter of the tree, the circumference of the tree, its irregular growth, and all of these factors. So it's really, Patrick's book, The Forest, when he talks about from the forest to the buildings, in the first chapter or so, second chapter, deals with that kind of thing. Yeah.
Question, how far away were the trees that they used for the roof?
That I do not know.
How would they transport?
They would always try to have it close, and they would always try to use water transport. So it was probably to the east in the Champagne, but you have navigable rivers and the Seine, of course. And before they started the project, they built this whole huge, long roadway. And we know that from documents in the cartulary of Paris, what talks about buildings that had to be torn down to make room for this kind of causeway for the builders. Any other?
Is all the repair and additional additions to the structure that happened that you noted, those are because of the shrinkage and losses?
It depends. It could be weathering, it could be rot, dry rot. The carpenters, the ideal situation is to have the back of your bracket, your truss away from the wall so it doesn't absorb the damp. There's a real problem with this new stone that Ville used because the limestone isn't of the same quality, so it absorbs much more moisture than the original stone quarry, which is underneath Paris today, not accessible. So you've got this spongy limestone. And even Ville says that the limestone is not of the same quality. So, but you've got this, penetrating damp. You go up there in the wintertime, there's definitely penetrating damp. And so there could have been some rotting of individual timbers, because there are replacements here and there. Yeah. So
it's possible that our grandchildren will be fixing our trusses.
You'll be fixing your trusses?
Yeah.
Oh, I don't know. If you build, well, it depends on where. What are you going to put the trusses on?
These models?
No, the big one.
They're gonna,
A wall?
you just said that they were going to, they're tilting it, you mean out here?
Yeah.
They're tilting it and it'll be on some L brackets that they remove, but they're gonna build it fix-off and raise it because the queen posts are, hanging below the.
Oh, so you use that as an English term, the hangers.
The false.
False.
Yes.
Yeah, well, see, the English did all this stuff wrong from from the French perspective. The English, all my English colleagues are going to fits. Because, I'm sorry, Julian, I'm sorry, Matt, all these people. But it's the truth. So, but then those English roofs, the open roofs are really impressive. They're gorgeous structures.
I have one more question for you. Since you're bringing up different approaches to making, the English, how do you feel about Western and Eastern?
You mean like a Chinese, Japanese?
Yeah,
kind of
like
timber?
the joinery timber.
Those are amazing joints, those nesting sort of joints. Those are phenomenal. Well, the wood is different. It's, I'm not sure what it is. It's not oak. For
No,
sure.
it's not, yeah, these different.
It might be some variety of pine. The ancient person is the Theophrastus, who wrote a book on, it's called on plants, but he has a huge section on trees. So he was going back to as some people in your lecture series, going back to well, this is actually back to the Greek period, translated into Latin, to the Roman period. But here's fun reading.
I'd like to,
Okay.
you shared the bibliography, would be great.
Okay, so
Thank you so much.
I think we're finished. Thank you all.
Thank you.
Thank you for the questions. Live students and a live presentation. Oh,
I'm just going to turn the webinar off. Bye, everyone online. Thank you. You can